Hey everybody, we're taking a look at this homework assignment, negative exponents. Looks a little bit yellow, orangish on the screen here, but it's actually a yellow if you were here in class today. If you weren't here in class today, that's okay. You can go ahead and print this out. PDF is in Canvas. Should be right above this where this video is posted. Also, there's class notes and some other videos that I posted if you missed class that you can go look at right above this post in Canvas. So real quick, let's talk about the negative exponent property. In symbolic form, I'm going to write this right at the top. Basically, when we have anything to a negative exponent, what we can do is we can push that expression down in like the fraction bar, and that exponent will become positive. We talked a little bit about why that's the case and how we kind of came up with that property in class today, but I'm going to show you in this assignment more or less how to use that property. Okay. So in the first four here, we're basically just going to apply the property, and then the last step is to evaluate, which is to give an actual number answer. So in this case, 6 to the negative 2 is the same thing as 1 over 6 to the positive 2. Okay, so notice I just kind of pushed the expression down, made it a fraction with a 1 on top, and now we can evaluate because we can actually do 6 to the 2. We know that's 36. Okay, so if you think about it for a second, 6 squared is 36. Okay, one of the things we talked about in class is that if we have a negative exponent, it's just a reciprocal of its positive exponent buddy. So 6 to the negative 2 is 1 over 36. So the positive exponent is 36, the negative exponent, same kind of idea, it's just in reciprocal form or like flipped over. Okay, let's do the same thing here. Alright, so we know this is 1 over 2 to the positive 4. And again, we can evaluate. 2 to the 4th is 16, so that's just 1 over 16. Okay, so 2 to the 4th power is actually 16. 2 to the negative 4 power is 1 over 16. So again, that negative here in the exponent gives you a kind of a clue that we're talking about a reciprocal, or like the flip version of a power of 2. So that's kind of what's going on. Okay, number 3, this is going to be 1 over 5 to the 3rd power. Okay, 5 to the 3rd power is 125. So 5 to the 3rd is 125. 5 to the negative 3 is 1 over 125. Again, that negative exponent just showing that we need to have a reciprocal here. Okay, 1 over 3 to the positive 4. So notice again, I'm kind of pushing it down to the bottom of the fraction, putting a 1 on top for a placeholder. And since we know what 3 to the 4th is, we can go ahead and evaluate there. So evaluate, that word evaluate means the answer is a number. A lot of times we have variables and we can't figure out what the actual number answer is. We just can simplify. So the difference between evaluate and simplify is simplify, our answer is going to be an expression. It's going to have variables in it. Evaluate means our answer is going to be a number. In this case, we got rational numbers. Okay. So here, this is a really silly analogy that I use in class, and it's not mine. I didn't make it up. It's kind of almost like a common analogy. But the analogy is, if you think about exponents like almost like a thought bubble, right? Like m is thinking of the power -3. Again, silly analogy, but whenever you have a variable that's thinking negatively or like thinking bad things, you can like send it down to the basement until it improves its attitude. All right, so kind of a silly analogy and something we wouldn't want to obviously do in real life, but it's just silly enough to help us remember. So we got r. Again, I kind of think of -4 as like maybe like a thought bubble. All right, so we're going to go, r is thinking negative. So we're going to send r down to the basement until it proves its attitude. Right, so r now has a +4 exponent. Okay? So these are actually pretty fast, pretty easy. P to the -1, we're going to do the same thing. 1 over p to the +1. Okay, well, we don't really need the final exponent of 1, so we're just going to do this. These are one-step problems here. All right, now they start to get a little bit more complicated. And in number 8, the difference here is that I have a 4 in front. So just so we know, this is 4 times k to the negative 3. Okay? So in this case, the 4 does not have a negative exponent. Only the k is being raised to the negative 3 power. And so what we're going to do is we're just going to send the k to the negative 3 down to the basement. 4 stays on top. We have k to the 3rd. All right. So there's a lot more going on, like mathematically here. We talked about a lot of this in class, and if you want to look in the notes or whatever, there's a couple examples of where this actually comes from. That's what we did in class. Here we're just trying to kind of break it down into nuts and bolts, and how does this actually work. All right. So we're going to start skipping around here because we don't need to do all of these, and you guys can do some of these on your own. But let's take a look at a few as we go. Okay, so in number 12 here, we got actually 11 and 12. We have variables in the bottom, and this property actually works kind of in reverse as well. So if we have something with a negative exponent in the bottom, we can just send it up to the top, and the exponent will become positive. So I'm just going to bring x to the positive 5 up to the top, and it's going to multiply the 6. The same thing is true here. But notice that I have a 17 in front. So this 17 is not being raised to the power of negative 12. It's being raised to the power of 1. So what we're going to do is we're going to send just the stuff with negative exponents up to the top, and then leave everything that doesn't have one. Now there was a 1 up here, but whenever this y to the 12 comes up and multiplies that 1, we don't really need it anymore. I mean, we could say this is 1 times y to the 12th, but it's the same thing. Okay, 13 is a little bit different because of the parentheses. So in this case, we send everybody to the basement because all of this stuff is being raised to the negative power. And notice the coefficient, or the number multiplying y, doesn't change. Regular numbers out in the front, we call those coefficients. Those don't change. Only the exponents are changing here. Okay, from here we need to apply one more property of exponents, and that is power property. So since these are in parentheses, both the negative 4 and the y are going to get the power of 3. And we can do negative 4 to the 3rd power. That's just negative 4 times negative 4 times negative 4, which is negative 64. And then we have y to the 3rd. Lastly, we usually don't leave the negative out in front, or out in the bottom of the exponent, so we can either put that out in the front of the fraction, or we can put it on the top. But that's going to be our final answer, something like that. Okay, so actually do most of these, but these are all like very basic problems. These are just kind of applying that property. There's not a lot of work to show here, but if there is more than one step, like in number 13, I would show those steps. If there's more than one property that you're applying, just kind of keep track of that. But for the most part, these are pretty quick. Since we did most of these, let's just go back and hit the rest of them. I was going to just do a few of them, but they're so quick. Okay, so here, the 4 is not being raised to the negative 2 power. It's being raised to the 1 power. We don't have parentheses here. So the 4 stays on top. We send the b to the negative 2 down to the basement. All right, similar thing over here. This is 3 to the 1, so the 3 stays on top. M goes down to the basement, becomes an m to the positive 1. Okay, and then 14. Now, be careful here, because a lot of students will see a negative and they'll be like, oh, I'll just move that negative down. It only works with exponents. So this negative 25 out here, we're not going to change that. That's going to just stay on top. What we do want to change, though, is the negative exponent. So this guy is going to head down to the bottom, downstairs, and we're going to make sure it has a positive exponent. I'm going to go box all my answers here. Okay, so that's just the basics of the negative exponent property. So let's take a look at the back, see what we got going on here. All right, now in this case we have multiple properties happening at the same time. So there's multiple orderings to do this. There's 7 properties of exponents that we talked about, 6 from last week. Product property, quotient property, the 3 power properties, etc., the 0 exponent property. The order that you apply those properties in is not really important in terms of getting the final answer. However, sometimes it will make your problem shorter if you do it in a specific order. So what I usually recommend is to use your negative exponent property at the very end. Do all your other properties first, and then at the very end come back and see what your exponents are. So let's talk about a couple different ways to do it. We're going to do, I think, the evens on this one. And you got the odd answers in your notes. So again, if it's one step, I don't need work. If it's more than one step, don't hold those steps in your head. I want to see what you're thinking, so write those steps down. Should take only an extra like maybe 10 seconds per problem just to kind of record what you're thinking. So go ahead and do that for me. All right, so let's take a look at this guy. Now right here we have n's over n's, and so the relevant property here is the quotient property. Okay, I have the 2 on the bottom, that's going to stay. But the quotient property says when I have n's over n's and they're raised to powers, I'm going to subtract the exponents. So what I have here is n squared. This is a little bit tricky, so kind of pay close attention. I'm subtracting the exponent on the bottom. But the exponent on the bottom happens to be negative already. So it's 2 minus a negative 1, which is kind of tricky. So when you think about what that means, 2 minus negative 1 is the same thing as 2 plus 1. And so I actually end up with n to the third over 2. Okay. So notice that I didn't even have to really move anything. I didn't really need the negative exponent property. Sometimes we'll use that as like a cleanup step. But in this case, just subtracting the negative exponent ended up with giving me a plus 1. Okay. Now there's another way to think about it. You don't have to do it, one way, because there's a little bit of flexibility here. So let's think about it from the other direction. What if we were to just move this guy up? So we'd have n squared on top, 2 on the bottom. When we move this guy up to the ceiling, basically, push him up to the attic, the exponent changes. So now we have n to the 2 times n to the 1. And we know we can use the product property here. We're going to add the exponents. 2 plus 1 is 3. Okay, so either way we get the same answer. Now, doing it this way, moving the negative exponent up, sometimes works kind of nice, but in more complicated problems like we're going to see down here, it's actually more work if you if you try to make all your negative exponents positive at the very beginning of the problem. So in this case you can do that, and it's kind of about the same either way. But again, I recommend using the properties like product property, quotient property, power properties first, and then at the very end, if there's any negative exponents at the end, then you can go back and adjust them. Okay, so let's take a look at number 18. So let's start with the fraction. 2 over 4 simplifies to 1 over 2. So I'm going to put a 2 on the bottom. We may end up having, we may need to write a 1 on the top, but for right now, if there's something else on top, we don't need to write the 1. So now we're going to do the quotient property. Now, anytime you do the quotient property, the result is always going to end up on the top. So just doing the quotient property, I got x on top, it's negative 1 minus 4. Okay, so negative 1 minus 4 is going to give me a negative 5. Okay, so now at the very end of the problem, now we can fix it. Now we can use the negative exponent property to clean it up. So I'm going to send x to the 5 down to the basement. So now this negative 5 is a positive 5. It's going to multiply the 2 that's already there. And since there's nothing left else in the top to see, I got to put a 1 there as a placeholder. Okay, so I use the quotient property here, subtracted the exponents, and then at the very end I use the negative exponent property to fix my answer so that my answer only contains positive exponents. Okay, now again, there's another way to do it, but the more complicated it gets, if you start moving stuff around too early, you're gonna end up repeating some work. Okay, let me show you an example here, number 20. I could move this x to the negative 3 down and make it at over x to the positive 3. But notice here that I have multiple different x's floating around. And so if I apply the product property first, I really don't have to worry too much about the negative exponents. So let's reorder this a little bit. Right, so I got 2 and a 2 and a y to the 1 and a y to the 1. Then I have an x to the negative 3 and an x to the 3. So I just put the coefficients up front, put the y's next, and then I put the x's. And usually we go in alphabetical order, but we'll fix this next. So 2 times 2 is 4. We can do that. Here we're going to use the product property. We'll get y squared because 1 plus 1 is 2. And then here we have negative 3 plus 3 since we're multiplying these guys. We have x to the 0, right? Negative 3 plus 3 is 0. And x to the 0 we know is going to be 1. So we actually don't even need this piece. And we just get 4y squared. So notice that I didn't really even apply the negative exponent property. I didn't need to move this x to the negative 3 down because when all was said and done, I didn't have any x's left anyway. So the exponents in these problems are going to change. And my recommendation is wait until they stop changing and then move them. Sometimes you'll have like a negative and then you'll change it and then it'll change back to a negative and then you have to keep moving stuff around. So just apply your properties the normal way, and at the very end of the problem, if you have negative exponents left over still, when the dust has settled on everything, then you can move them. Okay. All right, so let's rearrange this guy. We got 5 times 6 times x to the 1 times x to the negative 7 times y to the 3rd. Just rearranging the different factors here. Remember, this is just multiplication. So I put the coefficients up front. That's going to give me a 30. I put the x's next, applying the product property, add the exponents. I'm going to have x to the negative 6, and then I have y to the 3rd. Last step to this problem is to clean up anything with a negative exponent, which is this guy. So the 30 stays on top, the y to the 3rd stays on top, the x to the negative 6 is going to get pushed down and become an x to the positive 6. All right. So here we're going to have the power properties. We have power of a product and the power property. So I'm going to put a 1 on that 3 because a really common mistake for students to do is to multiply negative 2 times 3 and get negative 6. But that's not what we're doing here. We're multiplying exponents. So this should be 3 to the 1 times negative 2. Okay? And then y to the negative 6 times negative 2. And since negative 6 times negative 2 is a positive 12, we're actually not going to have to worry about the negative exponents on those y's. What we will do, though, is we'll take care of this guy. So y to the 12th is going to stay on top. 3 squared is going to get moved below. And then we're going to make that a 9. We're going to evaluate that, just that part. The 3 squared we can evaluate to 9. All right. Okay, similar problem in number 26. Again, we're going to start with the power properties. Before we start moving stuff around, these variables are all still changing. They're all kind of still in flux. So we don't want to start fixing stuff until we see what the final exponents are. Sorry, I said variables. What I meant is the exponents are still going to change. We're going to get this multiplication. So let's not change anything yet. We got 2 to the 1 times negative 4. We got a to the negative 3 times negative 4. And then we got b to the 6 times negative 4. Okay, so notice all the exponents just changed. So we don't want to use the negative exponent property to change them from negative to positive just yet because they're still adjusting. All right, now that they're not changing anymore, now we can just move anything that still has a negative exponent. Notice the a that had a negative exponent now has a positive exponent. So we actually don't have to worry about that one. So 2 to the positive 4, b to the positive 24. Right, only the powers are changing sign here. And then we'll just clean it up a little bit. 2 to the 4th power we can do. That's 2 times 2 times 2 times 2, which we know is 16. All right, so 28 and 30 are both quotients, or you're seeing a division or a fraction here. Again, very common for students to want to just move this down to the basement, move this up to the top, which you actually could do. It's just you're going to repeat steps if you do that at first. So instead of trying to move around your negative exponents to get them to be positive at the beginning of the problem, again, we want to wait till the end. So let's just use our properties here. Now I do notice that there are multiple b's on the bottom and there's multiple numbers. So we talked a little bit about the most efficient way to simplify. So I'm going to simplify just that denominator first before I start using my quotient rule. So I got 10, a to the 9th, b to the negative 10th. The top is fine. The bottom, I should probably have an 80, 8 times 10, and then b to the negative 7 plus 6. It's going to be b to the negative 1. Okay. Now you could have canceled out the 10s ahead of time and just, you would have had that 8 there still. It's kind of, there's multiple ways to get there. Now that we have 10 and 80, this is going to simplify to, 1 over 8, so that's going to be the same either way. Okay, but let's look at the a's. So we only have one set of a's, just a to the 9th. Okay, so that a and that 9 look kind of similar, but I'm going to try to put a little tail on the a so you can tell. All right, now we have the b's. So what I'm going to have here is b, just using the quotient rule, to the negative 10 minus negative 1. All right, it's a little bit hard to see there because the exponents are kind of small. But I'm subtracting the exponents according to the quotient property. I have a negative 10, and I'm going to subtract a negative 1. So off to the side, that looks like this. Remember that when you subtract a negative, it's the same thing as just adding. And so that's going to come out as a negative 9. So getting a little short on room here, that's okay. We got a to the 9th, b to the negative 9 over 8. And then our last move is to apply the negative exponent property. So we'll bring that b to the negative 9 down. So again, I know that's a little bit small for you guys to see. Let's see if I can zoom in a little bit. We got a to the 9th power over 8 times b to the 9th power. All right. Okay, let's move on here. Again, we have a quotient here, but I noticed that there are some numbers and some similar variables in the top. So let's just take care of the numerator first, then we'll do quotient stuff, and then if there's any negative exponents left over, we'll fix them at the very, very end. So we got a 2 and a 6, that's a 12. We got x to the 10th power, and then we have a y to the negative 6 and a y to the 4th. So according to the product property, you're going to add those exponents, which will give you a negative 2. On the bottom, we have x to the 8th and y to the 2. Okay, so let's keep going. Let's simplify. Now, when you use the quotient rule, I said this before, but it's important, you always want to put the variable on top. Whenever you use the quotient rule, the result of the quotient rule or quotient property goes on the top. If you have to move something later because of it's a negative exponent, you can do that, but let's start on the top. So what I have here is 12 on the top, and then x, and then I'm going to do 10 minus 8. We know that's going to be 2, but we'll simplify in a minute. Okay, now let's do y. Again, quotient property, we're subtracting exponents, but this time it's a negative 2 minus 2. All right, so we got 12x to the 2, because 10 minus 8 is 2. But negative 2 minus 2 is actually negative 4. So now all the exponents are done changing. We've added some together, we've subtracted some. They're not changing anymore. So now let's use that negative exponent property. Let's move the y to the negative 4 down to the bottom. And then we're good. Okay. So again, I know I've said this a lot, but I'm just trying to get across a point here. This y to the negative 6, I could have moved that at the very beginning. I could have pushed this down to the bottom and said, okay, go with that y to the 2. And you might have wanted to do that, and that's okay if you do that. But the thing is when your exponents are changing, sometimes it's hard to predict which ones are going to end up negative and which ones are going to end up positive. For example, if I put this y to the 6th down here, I'm going to have y to the 8th. Then if I use the quotient rule, I'm going to have to do a 4 minus 8, which is going to give me a negative exponent, which means I'm going to have to move it back up to the top later, or back to the bottom anyway. So a lot of times, if you move stuff at the beginning of the problem, once the variables all change and you subtract stuff and add stuff, you maybe have to move it back to where it started anyway, or move it again. And just to avoid repeating the same step over and over, it's helpful to just do that step one time at the very end of the problem just to finish out. So I recommend that you use the product property and the quotient property and the power properties first, and then use your negative exponent property as a cleanup at the very end. Okay, so you got the odds on here. I'm not going to do all these. You have the answers to these But you want to work through them yourselves and make sure that you are getting the right answer. They kind of match in style pretty close. They're not the exact same problem, but they're similar kinds of problems across the board here. So if you understand 24 and 26, then you probably get 23 and 25, and so on. So try those out. See what you can come up with. Check the answer key. Make sure you're checking your work so you know where you're going wrong. And on these ones that are multiple steps, show me some steps. Show me some work so that I can see your thought process. Thanks for watching.